Your brain is an astonishing organ made up of roughly 60% fat by dry weight. Those aren't just any fats. They're specialized lipids like omega-3s and cholesterol that wrap around nerve fibers, acting as insulation so electrical signals can travel at incredible speeds without interference. Without enough of these healthy fats from sources like fish, nuts, or seeds, your cognitive performance can dip noticeably. Focus blurs, memories become fuzzier, and even mood regulation suffers. Recent studies have shown that increasing certain brain-specific fats in experimental models can partially reverse some effects of aging on neural function, highlighting how diet literally nourishes the hardware of thought. It's a quiet reminder that what you eat today is building or rebuilding the very structure that lets you think tomorrow. That same brain, weighing only about 3 pounds, constantly generates around 20 watts of electrical power, enough to faintly illuminate a small LED bulb. This energy powers roughly 86 billion neurons and trillions of connections, burning through 20 to 25% of your body's total calories, even at complete rest. Advanced imaging techniques now capture this activity in real time, revealing bursts of glowing neuron clusters during moments of insight, creativity, or intense problem solving, like tiny fireworks displays lighting up inside your skull. Every fleeting thought, every decision, every daydream draws from this internal power plant. You're essentially carrying a living supercomputer that's always running, quietly consuming fuel to keep your inner world alive and processing. One of the strangest truths is that the brain itself has no pain receptors whatsoever. Surgeons can operate directly on brain tissue while patients remain fully awake, conversing, solving puzzles, or even playing instruments, because the cutting causes zero sensation in the neural matter. Pain signals come only from the surrounding scalp, skull bones, and protective membranes. This explains why headaches feel so intense. They stem from tension in blood vessels, muscles, or those outer layers, not from the brain protesting. It's a design quirk that allows incredible medical precision while reminding us how disconnected our sense of self can be from the organ that creates it. Your brain never stops physically changing. Whenever you learn something new, whether a skill, a fact, or even a different way of looking at an old problem, new connections form between neurons, and unused ones gradually prune away in a process called neuroplasticity. Recent research confirms that even in adulthood, new neurons continue to emerge in areas like the hippocampus, especially when you exercise regularly, pick up languages, meditate, or tackle complex challenges. People who commit to learning show measurable increases in brain volume and connectivity within months. This means you're not fixed in who you are. Every effort literally reshapes the hardware. The guitar chords you're practicing, the new recipe you're memorizing, the book you're reading, they're all sculpting fresh pathways right now. Attention is fragile in our modern world. On average, human focus lasts about 8 seconds before drifting, shorter than the 9 seconds typical for a goldfish. This isn't a personal failing. It's the result of constant notifications, multitasking, and endless streams of information hijacking the brain's reward system with quick dopamine hits. Yet the capacity for deep focus is still there, wired from evolutionary times when sustained attention meant survival. Techniques like mindfulness, single tasking, or even short periods of deliberate boredom can stretch that span back out. Emerging tools, including brain-computer interfaces, are helping people regain control over wandering minds. Your brain evolved for depth, not distraction. Reclaiming it starts with choosing where to point it. Zooming far beyond the skull, Earth might sit inside a vast cosmic void, a bubble of unusually low matter density stretching hundreds of millions to perhaps 2 billion light-years across. Recent astronomical data, including signals from the early universe's sound waves, baryon acoustic oscillations, suggest this underdense region could explain why the universe appears to expand faster in our local measurements than in others, the Hubble tension puzzle. It's as if we're viewing reality from inside a giant transparent sphere that warps our perspective. Everything telescopes show is slightly distorted because we're not in an average patch of space. The scale is dizzying. Your mind, built to navigate forests and cities, strains to picture a near-empty expanse larger than imagination itself. The observable universe contains an estimated 200 billion trillion stars, far more than all the grains of sand on every beach, desert, and seafloor combined. That's just the visible portion. Beyond the cosmic horizon lie unknowns. Each star is a potential sun with planets, some possibly hosting life forms staring back at their own night skies, wondering about distant specks like us. When you look up on a clear night, you're not seeing a static backdrop. You're peering into an ocean of possibility so vast that human language and intuition fall short. The brain recoils from infinity because it evolved for the finite and immediate, yet that same brain is the only thing in the known cosmos capable of grasping even a fragment of this enormity. Octopuses stand out as one of nature's most alien intelligences right here on Earth. 2/3 of their roughly 500 million neurons reside not in a central brain, but distributed across their 8 arms, allowing each limb to sense, taste, decide, and act with a high degree of independence. They solve complex puzzles, use tools, escape enclosures through tiny gaps, plan ahead, and even edit their own RNA on the fly to adapt proteins quickly, something almost no other animal does. Their copper-based blue blood and 3 hearts add to the otherworldly profile. When an octopus multitasks or camouflages instantly, it's not one unified mind directing everything. It's a decentralized network of semi-autonomous parts collaborating. This distributed intelligence challenges our assumption that smarts require a single headquarters. Your brain's theoretical storage capacity reaches around 2.5 petabytes, equivalent to 2.5 million gigabytes, or enough space for about 3 million hours of high-definition video. You could theoretically store centuries of continuous footage without running out of room. In practice, though, the brain prioritizes emotionally charged, survival-relevant information over trivia, which is why mundane details slip away while vivid moments stick. Dreams play a key role here too, processing daily experiences and rehearsing scenarios, often with a bias toward threats. Every night, your brain runs simulations in sleep, strengthening useful pathways and clearing noise. The irony is profound. An organ with near-limitless potential foreholds forgets where it left the keys while retaining the scent of childhood rain decades later. Even the earliest memories form sooner than once believed. Babies encode experiences in the womb and in the first days of life. Yet most of those fade as the developing brain aggressively prunes connections to streamline for future learning. Somewhere inside every adult are faint, erased traces of floating warmth, muffled heartbeats, and dim light. Ghost files deleted to make space. It's a bittersweet efficiency. The mind clears its archive not out of cruelty, but to keep evolving. What remains is a curated story of who you became, built on the quiet erasure of what you once were.